Okay, once again, we're talking about exponential functions. Exponential functions are of the form f of x equals c times a to the x power. That's just a general function, just general rule for an exponential function because the exponent is a variable. The variable is in an exponent form, so therefore we've got an exponential function. If I give you this information, then c is my starting value or starting amount. So if that starting amount is c, then that happens that we get our c value only when x is equal to 0. Because if x is equal to 0, let's set up an xy table. If x is equal to 0, then a to the 0 power is 1. A to the 0 power would be 1. And I've got my f of 0 is c times 1 is my c value. So whether I've got this graph over here, that's a 0, whether I've got that graph over here, my starting amount would be 0 comma c. Whether I've got this graph over here, my starting amount would be 0 comma c. When x is equal to 0, my value for the function is c. So there's our starting amount. Starting amount is always 0 comma c. The other piece of information is a. If a is greater than 1, then we could say that every time we go forward from, let's say x is equal to 0 to x equals 1, let's say in a specific situation that this a value were 2. So I'd start with some at x equals 0, y value of c. X equals 1, y value of c times 2 would be 2c. We could also go up here into our function and say, well, if x equals 1 and a equals 2, I'm just put out some numbers here just so we can kind of play with the idea that if a is greater than 1, we've got our a greater than 1, we're multiplying c by that number that's greater than 1 to get a larger value. Same idea is if we go back up to our function and say that if x is equal to 1 and our a is equal to 2, then 2 to the first power is 2, and my f of 2 is c times 2, which is 2c. So that means if I'm starting over here at some value of, well, let's say 0 and went up to 1, then I would take this, multiply by 2 to get up here to my 2c value. If I go forward another in my x, if I go to, for example, x equals 2, then I'm multiplying again by 2. I'm multiplying this value by 2. So instead of at x equals 2, this value would be multiplied again by 2 by my a value to get to 4c. Because if we go back up here, a to the x power, if my a is 2 and my x is 2, then 2 to the second power, a is 2, x is 2, 2 to the second power is 4. 4 times c is 4c. So f of x, or y value, is f of 2 is c times 4, 4c. And every time we go forward one tick in the x, we're multiplying by 2. Go forward, multiply by 2. Go forward, multiply by 2. That's the idea of a is greater than 1. If a is greater than 1, then we have growth. Because every time we move forward in our x, we're multiplying by something that's greater than 1, and we're getting bigger. The opposite is also true. And the specific situation would be is if a is less than 1, but greater than 0. That's kind of a criteria that we have, that a has to be greater than 0. But if a is less than 1, then we take our xy table and we kind of create this scenario. I've got my 0 starting amount. I've got c. A to the 0th power is 1 times c gives me c. Sounds good. Well, if if x is 1, and a is, let's say, for this situation, let's put a number in here and say if a is 1/2. If a is 1/2, then we take this c multiplied by my a of 1/2, and I get 1/2 c. Or if we go back to our equation, if I say a is 1/2 in the specific blue situation that I'm kind of creating, if a is 1/2, that's greater than 1, or sorry, smaller than 1. A is 1/2, smaller than 1, and I take it to the first power because x is equal to 1. 1/2 to the first power is 1/2. 1/2 times c gives me 1/2 of c. And essentially then, for every time I move forward, I'm multiplying by my a, multiplying by 1/2, and making my values smaller. So I'm going forward one step in my x, and I'm multiplying by 1/2. I go another step forward in my x, and I multiply by 1/2. So if a is 1/2, that means that I've got a situation here where a is between 0 and 1. If a is between 0 and 1, then I've got decay. And decay graph looks like this. Growth graph looks like this. Decay graph looks like this. Growth happens when a is greater than 1. Decay happens when a is less than 1. Also has to be greater than 0. And there's our situations for, just in general, growth and decay.